Problem 10 has a car going around 200-foot radius curve. We're given at a particular time the car has a speed of 58 feet per second. Alright, so I'm going to start writing some of this down. R is 200 feet. Velocity is 58 feet per second. Speed is increasing. Okay, that tells us where speed is getting larger. Our tangential acceleration is positive. So I'll make a note of that. Its total acceleration is given as 19 feet per second squared. How fast will the car be going 2 seconds later? So we'll have a delta t of 2 seconds. Okay. This hopefully reminds you of the problems where we worked and related the total acceleration to the tangential and the normal acceleration. So we had an equation, total acceleration squared is equal to tangential acceleration squared plus the normal acceleration squared. So that's a key concept. Remember, the tangential and normal acceleration were perpendicular to each other, and so this is basically the Pythagorean theorem. Okay, so we're given a total. We need to know the tangential acceleration because we want to find its speed 2 seconds later. Okay, so we're going to eventually use equation v equals v0 plus tangential acceleration times time. Alright, so we know the initial velocity, we know our time, so we need to find the tangential acceleration to find that final velocity. Alright, to find the tangential acceleration, we know the total acceleration, and we also need to remember that a sub n is a function of v and r. A(n) equals v squared over r. So the normal or centripetal acceleration is that equation. Okay. So we can write out this equation here as the total acceleration, 19 feet per second squared, is equal to a sub t squared plus v squared, which was 58 feet per second quantity squared, over r, which was 200 feet, okay, and we have to remember this is our a sub n, and so this whole quantity gets squared. If you were to look at the units, that would be a clue that you might forget to square it. You have feet squared divided by feet, so you have feet per second squared inside the square brackets here, and on the left side you have feet squared over seconds to the fourth. Okay, so everything would have to be squared here. Anyway, we can solve for a sub t from this equation. Okay, so I'll do that quickly. I'm just going to do 19 squared minus 58. Now let's do it this way. Parenthesis 58 squared divided by 200 quantity squared. And looks like I missed my minus sign in there. Okay, so that will give me a sub t squared, and if I take the square root of that, I get 8.837 feet per second squared. Okay, then I'll just come back over to this equation and solve for V. So V is equal to V0, which is 58 feet per second, plus A sub t, 8.837 times 2 seconds. Alright, and in the calculator, multiply that by 2 and add 58 to it. Looks like 75.7. How fast will the car be going? So we've got a speed, 75.7 feet per second. Okay, the reason why we needed to know that was increasing is in this step right here we actually took the square root, so it could have been plus or minus. Okay, so the increasing told us that it was the positive value.